Alright, so I found a bug here where when I tried to test it with the simple hashmark create, it throws an error because it enters this block for checking resize. So I'll just quickly check that map dash buckets size. I think this is it, buckets size. Though I'm not sure. Yeah, bucket size. Yeah. Okay. So this is bucket size. Um, should not be 0, and then you can do your thing over here. We put this condition. Okay, hold up. So when I have static, right, when I create static, what does it do? I think, okay, bucket size is already decided, but the load factor is 0. Create dynamic, create static. Okay, compare. Here we set the bucket size, yes, and collect. So okay, so load are 0, right? So bucket size is set only, but in case of static it does not. So why doesn't it resize? Go through the resize function. Okay, does it check something here? No. Okay, so check if the size is threshold. Now I have to bucket again that gets resized. Okay, call the function for resizing. Okay, if get size is equal to threshold. Okay, so it computes threshold. Right. Okay. Let me check this bit. This works, right? This works, right? So this works. I can create static. So I want to jump to this function. Okay. Create static. So I check bucket size. We provide a bucket size, and then I set a bucket size, right? And then I have a bucket size. So alright, so why doesn't it resize? We create dynamic. I bet it would enter this, right? This map buckets. You would create a new bucket. Oh, so is it creating bucket? Okay, so minor change. We check if the load factor is not 0, so that this would terminate for the cases if load factor is 0, means we don't want to resize. It shall be true for static and default create functions. So let's see this. Okay, great. And is to check that create dynamic, it works. right? Should test resize. Okay, so resize gets called, and there we go. Okay, great. Okay, so if I can also call load factor, right? If there is something in the load factor, there is something in the load factor, and let me just try the default implementation. Default. There we go, default. And okay, great. Okay, so now I will be implementing a beta hash. So I'll just copy these values. Source. Okay. So I have going to be better default hash. So let me take a look at default hash real quick. There we go. This is original code. I'm going to define a new default hash. There we go. New default hash uses murmur 332 hash function. Okay. Okay, so I think it should murmur 3.h 3.h here, murmur 3.h what should I'll combine it in DL goes 3.h. So there we go, 32. This is default hash, and we need a string. Right, a const void a. Okay. Yes. Default hash default. Okay, it is a static function only defined in this file. So so I'll first convert this b string key equals b string a, right? Okay. Oh, clever. Okay, so we don't need to create. We'll just say size t len equals b length of b string a, right? Another b string a, and similarly I'll get a pointer to the unsigned integer 8 key to the b data b string of a b data b string and then I simply return what was the function again? We'll see the hardware. Huh. Oh. Source. Let's see the hardware. 3 dot C. Okay. So my method underscore 32. Go murmur 3 underscore 32 with key and then passing the length. Okay, so this function will generate a hash. So I make clean W, then I rebuild tag here. Right. Okay, so it opens it up. Right, so I think it should all work fine. Debug.h, yes. Remember, run see the hard way dash this, and same for its implementation. This is learn see the hard way. Okay. Clear, make clean, and then make. Alright, and check this that it works with dynamic map. So go ahead make. Alright. Okay, so go improvement 3 done. Improvement is done. Okay, now the fourth one is this and nearly every hash map is vulnerable to someone picking keys that will fill only one bucket and then tricking your program into processing them. This makes your program run slower because it changes from processing a hash map. Okay, see that I have tackled. Okay. Improvement 4. Okay. Right, so run slower because it changes from processing a hash map to effectively processing a single D array. Huh. It will only pick keys. Okay. How to add randomness to hash functions? Why? Okay. And say the good hash is AB random p. I cannot find this hash function in any libraries in programming language, especially in Java. Okay, both answers miss the mark. Chula talks about salting hashes with random salts, and one talks about something else entirely. Okay, the hash function you talk about, it does have random A and B, but it only gets the random A and B once. Then uses the same values for those through the lifetime of your data. Okay. Otherwise, you could. Otherwise, you could end up with a scenario where the same value has different hashes, right? And that. basically what I thought. To distinguish why they're different, the hash listed is good for randomly distributing values in bucket as needed by a hash table. Okay, so basically, okay, so we random solve. So we start with the seed, right? We start with the random seed, and I can make it. There you go. I can have a random seed, say in static random seed equals srand, and then I pass in time, something like that, right? Hmm. So fetches the random seed. Rand function is defined in okay, fetches the random seed once for the lifetime of the program. Then we set it to random seed. Okay, let me try this. I've made it statics, so it will right. So however many times this function is called, it will retain its value, right? This is only set once, random seed. Okay, so we have random seed. I would need for rand function stdlib.h, I think, and time.h. Let me check if rand function c is defined. Okay, rand man page. So this is stdlib, right? And time and page. Okay, time.h, time.h, and right, time underscore t. Okay, so it does have a time type. Okay, ran srand unsigned int t. Um, okay, so basically I can do this, right? I think I have seen this somewhere. Maybe when we were creating random values, I had seen uses of srand with time t. Yeah, time t, rand function. Nope. This time is for something else. Check order. Srand time and underscore null. Okay, that's how you feed the time. Okay, that's how you feed. Okay. That's how you with. That's how you feed with time. Current time. Okay, that's all right. Okay. So, where can I call this function? Um, I'll just go random seed, and we'll pass it to unsigned int 32 bit, right? Rand. Okay. So this will feed once, right? Generate a random number. Feed once for the lifetime of the program, and anything w Then I don't really need time. Um, let's take a look. Huh. Yeah, sure. Hmm. Let's see. Alright. Error. Initializer element is not a constant. Huh. It's okay. This value is not a constant. Okay. I'm declaring it static. Um, can I create a global seed? Okay, wait. Let me see what happens now. Hmm. Okay, error initializer is not constant. Okay, and if I get rid of the static, then it works, right? Then yep, wrong value for testing, obviously. Okay, so static values, seed. Alright, so I think I'll create a const and 32 seed equals okay, I should include this block of code should only run once, right? m.h. If it gets included only once, it will run only once. So srand time null. Alright. Seed it with the current time, and then I go rand. Is this fine? Okay. I'll start with a 0. Random sort. Okay. Initializer element is not constant. Okay. Expected declaration specifier before its time. Okay, so it needs a random key, right? Seed. Okay, what if I go seed is just this rand. Okay, error expected declaration specifiers. Okay, forget about this. And I cast it to be unsigned integer 30, 32t. Will this work? Initializer element is not constant. Okay, so globals need to be constant. Huh. Unsigned 32t, unsigned 32t. So basically this is how I generate a random number, but okay, so let me just write out the fourth improvement and we'll struggle about this. 4 is this, and nearly every hash map is vulnerable. It is someone picking keys that will fill only one bucket, and then tricking your program into processing them. Okay. This then makes your program run slower because it changes from processing a hash map to effectively, I forgot the V, effectively processing a single DL. Okay. Now if we sort the nodes in the bucket, which I do, this helps, but you can also use beta hashing function, which I'm already using, functions, and for the really paranoid programmer, add a random salt so that keys can't be predicted. Okay, so here is what I can do. I can take in a seed, okay. We will not generate the seed here. We will store it in the map itself. Right, go seed. Okay, this will be initialized ones, and then used for the lifetime of the program. Okay, so you cannot initialize globals uh, from variables, from non-constant variables, right? Okay. All right. So we have create with hashmap create. Okay, then we go map seed equals rand, and then we cast it to be a 32-bit integer. Okay. Downsizing, will that work? Hashmap tests. Which one do I have? Great. Let's get back. Get to basic. Right. And then I will pass the seed and then I'll pass the seed here. Ooh, default hash. Now it needs a map too. Void a comma sign in 32t seed. Yeah, there we go. Seed. Alright. So where is default hash? Default hash is there. Where is default hash called? Okay, hash, wherever hash is called. Hash map hash is this. Okay, but where is this exactly called? Hash function. There we go. Comma map seed. And that's the only place this gets called. Okay, map hash. Okay, there we go. Next, setting values. We are calling this function. We're setting values, and we are calling it. Okay, great. So improvement 4, part of improvement 4. Now the hash function takes in an additional seed. Okay, so I can go make w and then make, or at least that work. Alright. Hash pointed I miss map and conditional expression. Pointed target initialization. Okay, cat star. Okay. Alright. So then hash map create default hash. Oh, because hash map hash is sorry, 32t feet. There we go. Okay, then this is done, and another is this. Okay, so it is 63. Okay, so it has to be pointed by a char array. So I cannot point it by anything else. Of course, it's a char, right? Okay, my bad. Alright, so there we will make w, then we will make, and there we go. Alright, can I print okay, so it just takes in a seed, right? It just takes in a seed, casting it to this. Okay, rand is how many bits? Unsigned unsigned int, so seed void. Okay, it returns the integer. Okay, so it returns the integer, so maximum 4 bytes, and then I can, oh yeah, okay, there's no harm in that. You convert a negative, take the positives to complement. I can even convert it to the positive you. So this code is perfectly right. Create hash map, create dynamic. There we go. Say part of improvement 4. Then I'll say part of improvement 4 and part of improvement 4. Okay, can't be predicted. So that keys can't be predicted. Okay, so yeah, okay, yeah, picking keys, right. 5 improvement 4 is also done. The arrays are, the nodes are stored in sorted fashion, right. We resize after reaching a threshold. So it is difficult. Okay. So it is difficult to store a lot of nodes in a single D array. And finally I add a random, generate a random seed every time the data is create a new hash map, which means the hash generated by one hash map will be slightly different than other. That you could have a delete buckets that are empty of nodes to save space. Okay, let's see what the fuss is about. Could have it. Okay, so you could have it delete buckets that are empty of nodes to save space, or put empty buckets into a cache. How can I put empty buckets into a cache? So you can save on time lost to a cache. So you can save time lost creating and destroying them. How? Okay, so this is the so how can I do this, right? Okay, let's check. Create dynamic. That's tree size. Okay, so here make. There we go. That's okay. Morning. Unused parameter seed. Murmur 30. Ah, dude. I never used it. My bad. Make. Yeah. Still doesn't make any difference. I just used the seed as initialized once and then passed along. My part of improvement 4. Okay, so let me test it with static 2. Okay, there we go, great. Alright, so here, okay, you could have it delete buckets that are empty of nodes to save space, or put empty buckets into a cache so you can save time lost creating and destroying them. You know, I don't think this is a good idea to delete buckets that are empty. Right, okay, buckets that are empty to delete. Delete as in, what do you mean by delete? You have to delete buckets that are empty of nodes to save space. Okay, so let's do one thing. Right, let me create the default one. Right, okay. So I'll write one test before. Okay, before delete. Right. So displaying the size of each bucket within the buckets. Okay, so here display size, display bucket, null. Okay, so I'll go for and I equals 0, I less than, what is the array count map dash buckets I plus plus, then Here bucket equal the array underscore get hash buckets of I if okay I'll go log info current bucket equal I right if bucket right we go log info bucket size. Okay, I just want to see which buckets are yeah, bucket size. Okay, great. Bucket size the count bucket, else if it is not there then we log info bucket size I'd say 0 0 I would say bucket don't exist, right? Okay, this is simple. DRA map buckets. Wow. Okay. Right, so I have this buckets, right? DRA buckets. So I want to run this test before deleting. So let me run test. This is test. Test display bucket. And here. And then let's hold up. But I do want to check I am using the default one, right? Okay, great. Okay, it is going to print a lot of things. Yeah, alright. Okay, so see, bucket these don't exist. Then I have bucket 14, which is a size 1. Then don't exist. Then I have this bucket 25 is size 1. Then we have 35. Okay, so that's why he was saying to delete, but how can I delete? Delete as in what? Delete as in what? Right, this is a thing to ponder. Yeah, okay. So maybe my code is not correct. I should not print everything. Right, okay, delete. So if bucket, then just bucket bucket okay. So I command this. Alright. Else I'll know the bucket is empty. Okay. So what do we find? that 14, 25, 35 and 96, only these buckets are, and I have allotted time. Okay, put buckets into a cache so you can save time lost creating and destroying them. Huh, buckets into a cache, I don't really get that. Okay, let me try with static buckets. How far, how good are these? Okay, put that there, yeah, okay, 0, 1, 4. That's good. 0 has 2, 1, 1. Okay, now let's try it with dynamic. I have, okay, let's try with dynamic, and let's also resize it. Um, so I get, huh, 4 into, that's great, maximum 1 to 2 per buckets. Total buckets, I think there are 8 buckets now. Should be no, 4, 5, 6. Oh, wow. Okay, so what could it possibly mean to, you could have it delete buckets that are empty of nodes to save space, or put buckets into cache so you can save time lost creating and destroying them. Okay, so if bucket exists and there is nothing in that bucket that are empty of nodes, so I should let that bucket go. You mean you're saying that, right? No, I think that is a costly operation because I will have to go through all the buckets, check. I don't think this is worth, but okay. Right now it just adds elements even if they already exist. Write an alternative set method that only adds an element if it is already set. Write an alternative set method that only adds an element and if it isn't set already. So I can go improvement spellings, improvement 6, done. Oh. Instead of not okay, write an alternative set method that only adds an element. Instead of not adding an element, okay, along with not adding an element, the value of that element gets overwritten. I think I have a test overwrite. There we go. Okay. Okay, so okay, I think that's about it for the most part, right? That's about it for the most part. Default hash. Um, Before passing it. Okay. Unable to find default hash. Well, okay. So when I actually use the default hash, right? Create function, create. I should check. Okay. Static inline. Shmap node create. We check the map. Okay. Key can be null. It's okay. Key can be null. It doesn't really matter. Just check the map and 32 and a hash out. This pointer should also not be null, right? I should check. You cannot set to a null value. Hash out not null. Error invalid. Hash out provided. Okay. And that's for most part. You could have it delete buckets. Okay. Deleting empty buckets and hash map. I want to read XML file, convert it to graphical graphics, but because the files are very large, check threshold becomes larger. Googling through the net, I tried to find ways to reduce the okay, a hash map typically is just a large array of references filled to a certain percentage of capacity. 50% of the map is filled, remaining 20 are unused. The extra overhead is really only just the empty cell null cells. On a 32-bit CPU, each array cell is 4 bytes in size, right? Although JVM allocates 8 bytes, yeah, that's really new space. Once the map is filled, you can copy it to another hash map with a more appropriate, smaller size, giving it a larger fill percentage. Your question seems to imply that they are more allocated but unused space that you're worried about. But how is that the case? Random. Once a map is filled almost to capacity, typically more than 95%, so a larger array is allocated. The old array's content are copied to the new array, and the smaller arrays have to be garbage collected. This is obviously an expensive operation, so choosing a reasonably large initial size for the map is key to improving performance. Okay. If you can overestimate the number of cells needed, pre-allocating a map can reduce or even eliminate the resizing. Okay. If you can overestimate the number of cells needed. Right, okay. To collection of short screen is not clear. Yeah, that's what I mean, right? Why? Why would you want to change the size of the map? So I will call it a day.